As we were discussing about the NDFA example, what we have seen that there are three states A, B, C, where A is your initial state and C is the final state. And in NDFA, on giving some input to a present state, we can reach to more than one state. So, if I will see the first row, on giving input 0 to the state A, we can reach to A and B both, and on giving input 1 to the state A, we reach to B only. If I will see the second row, then what we can see that on giving input 0 to the present state B, we reaches to state C, and on giving input 1 to the present state B, we can reach to either A and C. Let's see the third row. On giving input 0 to C, it reaches to B and C, and on giving input 1 to the present state C, it reaches to C itself. Let's see the diagrammatic representation. There are three circles A, B, C, where A is your initial state because an incoming arrow is there, and a C is your final state. Again, C is missing. C is the final state because it is represented by a double circle. Now, see the arrow. If I will see the state A, on giving input 0 to the state A, because there is a self loop over A and it is labeled by the 0, it means that on giving input 0 to the state A, it reaches to state A itself, and giving input 0 and 1, it reaches to the state B. It means that on giving input 0 to A, it can reaches to B, and on giving input 1 to the state A, it can reaches to B. And what we have seen that if I will see the B, on giving input 0, we reaches to the state C, and on giving input 1 to the state B, we can reach to C and we can reach to A also. And if I will see the C, on giving input 0, it reaches to B and C itself, and on giving input 1, it reaches to C itself because there is a self loop. Now I will explain the NDFA with an example. You are staying at the Ratu Road, and either you have to reach to Piscamore or either you have to reach to Harmo. And also there is the third destination, that is main road. So either from Ratu Road you can move to Piscamore, or you can move to Harmo, or you can move to main road. So on giving rupees 10, you will reach to main road, and on giving rupees 5, you will reach to either Piscamore or Harmo. The cost for travelling from Ratu Road to Piscamore is rupees 5, and same the cost for travelling from Ratu Road to Harmo is rupees 5. So what I can see that on giving input 10, it means that on giving rupees 10 from Ratu Road, I will reach to main road, and on giving rupees 5 from the Ratu Road, either I can reach to Piscamore or either I can reach to Harmo. So it is not deterministic whether I will go, if I will go to Harmo or I will go to Piscamore. That's why it is called non-deterministic finite automata. It is not determined that on giving some input whether it reaches to this state or that state. Now let's move to the difference between the DFA and the NDFA. If I will compare the power of the deterministic finite automata and non-deterministic finite automata, the power is same because NDFA can be converted to a DFA. Let's see the first difference. In DFA, the transition from a state is to a single particular next state for each input symbol. Hence, it is called deterministic. And in NDFA, the transition from a state can be multiple next state for each input symbol. Hence, it is called non-deterministic. Hope you have understood the difference between DFA and NDFA. In DFA, empty string transitions are not seen in DFA, while in NDFA, empty string transitions can be seen. This empty string transition will be explained by me in the coming lectures. Backtracking is allowed in DFA, while NDFA does not support backtracking. DFA requires more space, while NDFA requires less space. In DFA, a string is accepted only if it transits or it moves to a final state, and in NDFA, a string is accepted by NDFA if at least one of all possible transition end is a final state. So this is the difference between DFA and NDFA. If I will tell the summary of the today's lecture, I have explained about the automata, what is finite automata, and the difference between deterministic finite automata and a non-deterministic finite automata. A deterministic finite automata is that on giving input to a state, it will reaches to another single state. But in non-deterministic finite automata, on giving some input, it reaches to more than one state. In the coming lectures, I will explain you how to convert a non-deterministic finite automata to a deterministic finite automata. Thank you. Hope you have enjoyed the learning.